Thank you so much, Sandy, and good morning, everybody. My name is Erica Groche. I am a Public Affairs Officer for NOAA's National Weather Service, including the Space Weather Prediction Center, or SWPC. So if you hear us refer to this organization as SWPC, that is the reason. This morning, experts from SWPC will provide information about the unfolding geomagnetic storm event that began with a series of solar flares on Wednesday morning. This call is for the working news media and is being recorded. If you do not want to be recorded, please hang up now. If you are not a member of the press, you're welcome to listen in, but please do not attempt to ask questions at this time. We need to reserve this time so reporters can ask their questions. And thank you so much for your patience with this. I know a couple people have had issues getting connected, but hopefully it is smooth sailing from now on. And today we have with us Sean Dahl, the service coordinator for the Space Weather Prediction Center. He will be the lead speaker for this media telecon. Also joining him is Brent Gordon, who is SWPC's chief of the Space Weather Services branch, Brian Brasher, SWPC's project manager, Rob Steenberg, a space scientist for SWPC, Mike Betway, the SWPC operations chief. Sandy, please explain the process for asking a question.
Certainly. If you'd like to ask a question, please press *1 on your phone. Please unmute your phone and record your name clearly when prompted. Your name is required for you to ask a question. If you need to withdraw it, please press *2. Thank you.
All right, thank you. And thank you, Sandy. I'm going to turn it over now to Sean Dahl.
All right, thank you, Erica. Thank you, Sandy. Welcome, everybody. As I mentioned, I'm Sean, service coordinator here at the Space Weather Prediction Center. And we decided to hold this because we have a very rare event on our hand. The last time that we issued a G4 watch, which is a Geomagnetic Storm Watch for severe levels, that 4 level on our 1 through 5 scale was 2005. We have a high confidence that a series of coronal mass ejections, which are blasts of energetic particles and magnetic fields that depart the sun, are directed right towards Earth. Some are catching up with other ones. So our level of confidence is high that we will have an arrival of this CME, or the beginning of these CMEs, as early as this evening, Eastern Daylight Time, kind of later in the evening perhaps. But the timing is, there's less certainty with the timing, so keep that in mind. If we do reach the G4 levels, the level of response could mean that there could be some infrastructure effects, but we have notified all of our infrastructure operators that we coordinate with, such as satellite operators, communication folks, satellite operators, and of course the power grid here in North America. So they are able and prepared to take mitigation efforts as much as possible throughout this event if it should unfold to the levels that we currently are anticipating. Also know that these levels, it does take things that we don't know yet to get to the severe levels on this scale. By that I mean we won't know until these CMEs arrive about 1 million miles from Earth at our NASA ACE satellite and our Discover NOAA satellite that monitors solar wind conditions. That's how we identify the arrival of these 1 million miles from Earth. At that point, when we see the CMEs arrive at the satellite, that's when we will know the intensity that may develop here at Earth by different things in the solar wind that we look for. That's when we'll have more certainty, and that's when we'll begin to issue warnings. So with the speed of these events, roughly we're talking an average speed here of around 800 kilometers per second. That basically means there could be about 20 minutes to 45 minutes of lead time given the variances in the potential speed of these arrival of these CMEs. When I say CME, I'm saying short for coronal mass ejection. The reason for all this is a giant, well, there's been 2 sunspot clusters, one in the northern hemisphere of the sun, one in the southern hemisphere of the sun. So even prior to Wednesday, we were experiencing a large number of solar flares. These are blasts of strong energy that come from the sun, and we detect these with one of our satellites here near Earth, one of the GOES satellites, and we measure those in X-ray flux strength. And we've been reaching the R1 levels quite frequently, R2 levels a lot, and even R3 levels on our scale, so that's into the strong realm. Beginning Wednesday, another sunspot cluster, that one was the northern hemisphere, and that's since rotated to and beyond the limb, but since then, we've had another sunspot cluster develop that is one of the largest ones and more complex ones that we've seen in the solar cycle, perhaps the most complex so far this cycle. And that region has begun producing flares as well, which was not unexpected. We've been expecting our probability has been continuing to go up throughout the latter part of this week. And sure enough, we've been having these flares and now the coronal mass ejections that can sometimes be associated with these. Additionally, one other piece of information I'll throw out there that has just happened is our NOAA Space Weather Scale covers 3 categories. One is HF radial blackouts, which is associated with solar flares. Of course, the geomagnetic storms that you're familiar with, the G scale, and then one called solar radiation storms, which is the S scale. We've been expecting that the region here is likely to produce a solar radiation storm at the S1 levels. That just happened. A warning just went out for that because it's in a favorable location now for arrival of some particles here at Earth. What does that mean? Not too much. That's the fairly low end of our scale. It does mean thing to some rocket launch operations and satellite operators, but at this point in time, it's nothing that can't be handled as far as we understand it. But the potential for stronger events, of course, does exist, and we'll see if any materialize. With that, I think I've given you the lowdown of everything that I want to bring up to you. The key point here is that critical infrastructure operators have been notified that this is the first G4 watch we've issued since 2005, and that the activity is not over. The region is rotating as the sun rotates, so although it's becoming, it did produce another coronal mass ejection overnight associated with another flare that we had at the R3 levels. That one is being analyzed now to see if there's any Earth-directed component to that, and I say that because as the region rotates, it becomes in a less favorable position to have a CME arrive and aim directly here at Earth. The other ones were aimed directly at Earth. However, it becomes more favorable for these radiation storms, which we are now beginning to see develop. With that, I am done, unless my colleagues here, Mike, Rob, or Brent, have something to add at this point. We are ready for Erica to take back, or Sandy, and distribute questions. Thank you.
Thank you, Sean. That was a fantastic overview, and the rest of our time is reserved for Q&A. And please, reporters, remember to give your name and affiliation when you ask a question. And Sandy, can you just remind reporters on the line how to ask a question before we get started?
Certainly. If they'd like to ask a question, please press *1. Please unmute your phone and record your name. Your name is required to ask a question. If you need to withdraw your question, please press *2. One moment while we get the first question in.
And if you know who you would like this question directed to, feel free to address that person, but it is not necessary.
Okay, one moment, please. Our first question comes from Marcia Dunn from AP. You may go ahead. Thank you.
Oh, hi. Thank you. Just quickly, I came in a little late, and if I could get the speaker identified who gave the presentation up till now, that'd be swell. But so many of these flares and CMEs have been happening. What's how many? Do you have any idea of how many flares and CMEs have been already happened just this week, so far this week? And what do you anticipate could be the worst situation here on Earth? I know they can take care of power grids and stuff, but could any cities in the United States be experiencing disruptions, for instance? Thanks. For power.
Okay, we understood and received the question. I can't tell you at this time because I just don't know. I don't have that figure in front of me, how many flares. And this will be difficult to give you an idea. I think what we'll do is focus on the R2 levels because the background level of the sun for some extensive amount of times has been sitting at the R1 levels. So we'll focus on R2 and above flares for you. We'll send that out to Erica and she can disseminate it accordingly to everybody. With that, as far as the worst situation expected here at Earth, that's tough to say, and I wouldn't want to speculate on that. However, severe levels is pretty extraordinary. It's a very rare event to happen. And when we notify the critical infrastructure operators, to include the power grid, they're able to adequately prepare to, spin up procedures, spin up and make sure alternate equipment is working and lines are at their top notch. They may suspect, but the key element here is that they know what's causing anything if the situation unfolds. Then they'll be able to take the proper steps to help mitigate and control any developing problems. The worst situation would be, historically would be something like from 1859, the year 1859, something we refer to as the Carrington event. It's called that because of the astronomer's name, is after who happened to notice a giant sunspot cluster was on the sun. And what happened is about 18 hours later, a CME arrived at Earth, unbeknown to the time it was causing this, of course. And extraordinary things happened. The Aurora was seen down as far as Central America. The reports maybe it was seen in Hawaii. So that's an extreme level event. That's a G5 level. We are not anticipating that, but we can, of course, not discount that we could reach kind of a low-end G5 here potentially as well. We are considering that, but we have no way of knowing that until the CMEs arrive a million miles from Earth of just how impactful these may be. So our best guess right now is the G3 to G4 levels, and that's what I have to offer you. I hope that helps you. And my name, sorry, is Sean. I was the speaker for this.
Okay, I was just going to ask if you could identify yourself. And when do you expect the 1 million mile mark to occur? This afternoon, tonight?
If our timing is absolutely perfect, it would be this evening, say somewhere around 8 o'clock Eastern Daylight Time, roughly, give or take a few hours. But that's if the timing's perfect. Like I said, we're less certain on the timing of these events, because we're talking about something from 93 million miles away. That's extremely difficult to forecast with a very good degree of accuracy, the arrival of these events, because there's so many things that go on in what we call the solar wind out there that can, make our timing measures off by hours here in some cases. But this one, we have a pretty good we have a very good high confidence level of an arrival at Earth. It's just less certain on the timing.
And one last question, if I might. So you think that Alabama...
Actually, I'm so sorry to cut you off, but I really want to make sure that other reporters get an opportunity to ask questions. So I'm going to send it back to Sandy for another question in just a moment. But for those who had problems with their connection, you are hearing from Sean Dahl, the service coordinator for SWPC. His name is spelled SHAWNDAHL. Thank you.
Okay, our
Sandy,
next...
can you take it to the next reporter? Yeah.
Yes. Our next reporter is Paul Gross. And Paul, can you please give all your affiliations for us?
Yes, meteorologist emeritus at WDIV-TV in Detroit. And just two very brief questions. First of all, the impulse that we're expecting, is this to be expected to be a single impulse, or because there have been multiple flares and things, is this going to be maybe a series of a couple or three of these hitting this evening? And then the second question is just simply the satellites you referenced, are those at the L1, L2 points, the Lagrangian points? I just want to know for my own knowledge about that. Thanks.
Hi, Paul. I'll start that for you. Yes, we're referring to the satellites that are located out at the L1, which is called the Lagrange point out there. That's a stable area that's easier to maintain and orbit directly between Earth and the Sun, as the Sun's gravity and the Earth's gravity kind of equalize right there, and it's a very easy place. As far as what we'd expect to see 1 million miles from Earth, that would be an arrival. What Paul's referring to, everybody, is something called a sudden impulse. What that means is it's a shock arrival. Think of a massive cold front, a very strong cold front, barreling into your location. And the winds suddenly go from nice calm and the birds tweeting to, bam, your trampoline is toppling over somebody's fence. Okay, that's what a sudden impulse is. That's a shock arrival, the beginning of the CME. But then what happens is when the cold front comes through, a strong one, right? The temperature doesn't necessarily drop immediately. Sometimes it takes a little time, and then the temperature begins to plummet as a continental polar air mass from Canada moves into your area. Similar here. After the shock arrival, then we'd anticipate to see the strong magnetic cloud carried along with the CME being stretched out from the sun. That's when we could see the magnetic field strength increase dramatically, 4, 5, 6, 7, 8 times the normal background level, depending on how strong this tends to be. And that's when we really start to see reactions. The one thing I'll throw out there for you all is this is a large measure of uncertainty, is it's very important to how the geomagnetic storm develops here at Earth or intensifies is the orientation of that magnetic field. This is not something we have to deal with in terrestrial weather. We know a front's coming, we know the temperature is going to drop and the winds are going to pick up. But with these magnetic clouds from these CMEs, think of a magnet. If you take two negative magnets and you try to put them together, they don't connect, right? Same thing here. We need to know what the orientation is because Earth's magnetic field is pointed northward. So think of your thumb pointing up, a thumbs up. Along comes the CME. If it's pointed the same direction as Earth, we may not get an initial strong reaction. We might, or we should, with the CME barreling into Earth, but then it may settle down. But if it turns south, the opposite of Earth, now the magnets connect, and that's when activity can really escalate. And this can vary throughout the extent of the event. And I think the last thing you asked about was would we see multiple shocks arrive out there at L1? Yes, we could. Some of these have caught up with others, so honestly, we're not quite sure what to anticipate here, although we do expect to see one nice shock arrival, followed by possibly another one or two as other CMEs have departed the sun. And do my colleagues have anything to add here?
Yeah, Paul, this is Brent Gordon. I think the only thing I'll add to that, Sean did a great job of describing our current situation. You know, this sunspot cluster has been sending off new, very large coronal mass ejections about every 6 to 12 hours. And, you know, the latest one happened overnight, I believe about 3 a.m. local Eastern Daylight Time. We anticipate that we're going to get one shock after another. We're really buckling down here to see what we get at this point.
Well, thank you very, very much. Appreciate it.
I'm sorry. Was that Brent who just spoke?
Yes, it was.
Okay, so for those on the call, that was Brent Gordon, BRENT GORDON, and he is the chief of the Space Weather Services branch for SWPC. Thank you.
Our next question comes from Jeff Bromfield from NPR News. You may go ahead, sir.
Hi there. Thank you so much for doing this. My question was, can you just explain how the mechanisms by which the CMEs can potentially damage systems on Earth? I mean, satellites, power lines. I noticed you mentioned pipelines. Like, how can they affect a pipeline on the ground? I assume that's like an oil or gas pipeline. And then also, how big is the sunspot complex in terms of the size of the Earth? Those are my two questions. Thank you.
Hi, Jeff. Sean here. I'll give you an idea of the sunspot group. We figured that somewhere around 16 times the diameter of Earth in its overall aerial coverage and extent. That's one of the largest spot clusters we've seen in some time. As far as your other questions, I'm going to turn that over to Robert Steenberg. He's our main space scientist here attached to the forecast office. Rob?
Okay, hello. In terms of CME effects on infrastructure, for instance, the power grid, when the CME arrives and carries its own magnetic field, as Sean mentioned earlier, depending on how that interacts with Earth's magnetic field, that magnetic field can fluctuate. And that fluctuating geomagnetic field, when you superimpose that over long conductors, things like pipelines and railroad tracks and power lines, it can induce current, and that's electrical current that's not supposed to be there. And so our role is to alert the operators of these different systems so that they're aware and can take actions to mitigate these kinds of impacts.
And is it a lot of current, or is it just like milliamps, or, is it enough to do real damage?
It starts out in the millivolts category, and is typically measured per mile or kilometer, so it's over some distance, and that can rise into the pulse level, and that's one of the aspects that people monitor.
Got it. Thank you.
Mm-hmm.
Our next question comes from Brian Sullivan from Bloomberg News.
Hi, thank you. Two quick questions. One is, I missed the first half of your presentation. How far south do you think the Aurora is going to be able to be seen? And then secondly, this big sunspot cluster, will it come back in a couple of weeks?
Thanks, Brian. We heard that. The second part of your question, no, it'll take a little longer than a couple of weeks, but yes, this one's pretty large. We'll see if it survives the full rotation and we see it return to the left side of the sun, what is actually the east side of the sun, here in several weeks. As far as how it would behave at that point, there's no telling, but usually these don't come around a second time packing as much of a punch as they did originally, but time will tell on that. And as far as how south the Aurora goes, once again, there's a lot of nuances to that. We don't like to get into the realm too much of auroral prediction. We leave that to private enterprises mainly, but the general trend for these events as they unfold, let's say we do get to G4 levels and a decent G4 at the right time in the late evening to, post-midnight hours, then the Aurora could perhaps be seen as far south as Alabama and Northern California. Do my colleagues have anything to add there?
Yeah, Sean, thanks. Brent Gordon here again. The only thing I'll add to that, Brian, is, with new technology in our phones, we've been seeing some amazing Aurora shots even further south. So things that the human eye can't see, your phone can. And so we'll be interested to see just how far south we're getting Aurora images this time.
Thank you.
Our next question comes from Jillian Goodman from Heat Map News. You may go ahead.
Hi, thanks so much for doing this. Obviously, the grid today looks quite different than it did in 2005. So I'm wondering, what are some of the actions that grid operators might take to mitigate this induced current? And I'm also especially wondering how this will affect the grid with more renewables on it. Obviously, if this is coming at night, could we expect increased activity on solar panels from, this radiation? And could it affect battery storage? What are the effects on these systems that are more oriented to renewables? Thanks.
Thanks, Jillian. Rob Steenberg is going to handle that for you.
Okay. Those are all good questions. In terms of the particle impact on solar panels, fortunately, with our atmosphere and magnetosphere, we don't have to worry about that on the Earth's surface. Now, satellites in space, particularly beyond our protective magnetosphere, do have to worry about that with regards to their solar panels. And you're right, the grid is different than it was in 2005 with the addition of renewables. But what's been excellent is we've been working with the power distribution community over the past decade to help them better understand space weather, and their engineers have taken that information and used it to build systems that can protect the power lines more rapidly than they could before. So we've seen improvements in technology on the grid that get triggered by these events and that work to protect their different assets. Other things they can do are simple things like deferring maintenance if they have scheduled maintenance and keeping systems online that they'll need during the event, and in some cases taking systems offline.
And I'll add one thing to that, Jillian. When we're talking about impacts to the power grid, we're talking about the high voltage transmission lines. That's where these currents can develop. It's not on anybody's line going from a small transformer to their home. It's only really developing on the high voltage transmission lines, which creates problems for the major transformers that control out that distribution. Thanks.
Thanks so much.
Our next question comes from Lynn Tai. You may go up from GP Media. You may go ahead.
Hi, Sean. A question for you. How long would you expect any disruptions from this solar storm on services, electricity, GPS, etc., to last until, say, if it starts from today, maybe within the next couple of days, or maybe until even next week? Do you have an idea that you could share?
Yeah, sure, Lynn. I'll give you my quick idea, but then I'll turn it over to Rob here, who really knows GPS very well. Lynn, when we're talking about these events, sometimes even though the storm is over, the geomagnetic part, the outer level of our atmosphere, the ionosphere, still stays very storm-like, if you will. Conditions going on out there that can continue to impact signals coming from GPS, creating potential signal loss or timing errors, making positional accuracy not spot on. With the storming itself, as that happens, this is kind of the beginning of the process. So those things begin to happen there, perhaps, but then it can continue even after the storm is over. And Rob, did you have something to add on the GPS?
Well, one of the primary impacts that people look for in GPS is a phenomenon called scintillation, where the transmissions from the satellite are reflected and refracted through the ionosphere. And the potential for that to happen more dramatically increases, particularly during geomagnetic storms. Other things that happen in the ionosphere that can linger for a few days after the storm are areas where basically the ionosphere almost goes away. It's composed of a lot of electrons, and you can see a depletion there, and that tends to affect high-frequency radio communications.
And the last thing I'll add from that is that low Earth orbiting satellites, the controllers there are really paying attention now, because what happens with things Rob described, the ionosphere kind of expands, it becomes more dense, the areas where these satellites are orbiting. And if they don't take the proper measures, then they can lose altitude because they're drag. It's called satellite drag. They slow down. So those are being accounted for as much as they can. So that's just another thing that's going out there in space, systems that we rely on, that we consider critical infrastructure. Thanks.
The next question comes from Assam Ahmed from the AFP. You may go ahead.
Hi, thank you. Could you sort of tell us where on Earth these effects are more likely to be felt? I understand, is it more in the northern hemisphere, and is it in any particular location within the northern hemisphere, or is that fairly uniform? And what are these sort of mitigation techniques or technologies for the power grid and so on?
Yeah, Sam, thanks for that. So let's all remember that these effects aren't just in the northern hemisphere, they're also happening in the southern hemisphere. We're having the similar issues near the polar regions and how far they extend towards the equator in the southern hemisphere. So places like Australia and New Zealand, for example, are always monitoring these situations as well. As far as what we would see here in the northern hemisphere and the extent of these, once again, it's difficult to say. There's a lot of nuances that go on, a lot of things that we just don't know as these situations unfold and develop, like where the currents are really going to drive and pick up on the power grid, what satellites are actually going to feel and notice things, what HF frequency communication systems are going to have problems. But what we do know is however far the Aurora oval extends, as like an overhead or near overhead, people that are trying to communicate with HF radio will have difficulty. And as far as Europe goes and compared to North America, there's changes and differences in how our geomagnetic latitude is. And here in North America, that kind of extends down further south in the upper Midwest and northeast part of our country, which means those areas are always a little more likely to see an aurora further south than, say, somebody much further to the west at the same latitude. Did any of my colleagues here have something to add?
Yeah, I'll chime in. Assam, this is Brent Gordon. You asked the specific technologies that the power grid is using. So in the U.S., in North America, the power grid is alternating current. What these storms are injecting into the power grid is DC current. And so I don't specifically understand the exact nature of these devices that they put on there, but essentially they are detecting these DC currents, and when they get to a level that's going to cause them concern, it's simply like a breaker. It trips and takes the line down, and they're able to move around it.
Okay, that makes sense. Thank you.
Our next question comes from John Mayer. You may go ahead from the KVAL News.
Thank you very much. John Mayer here. My question, if I wrote this down correctly, we would have about 20 to 45 minutes of lead time for any sort of a warning. What exactly would that messaging look like if this was reaching a point where it would cause, or at least be expected to cause, some major issues? And I think this has basically been answered, but just to double check, is there anything that the average person should be doing to prepare for this event, be ready for any of the impacts, especially in terms of power grid? Should there be anything that they do in advance of this storm actually hitting? Thank you.
Yeah, thanks for that, John. As far as what the general public should be doing, hopefully they're not having to do anything. And the reason I say that is everybody should always have a plan, batteries, whether radio, perhaps a generator, depending on where you live in the country and how prone you are to normal power outages. These preparations are the same thing we'd recommend anybody have regarding space weather storms. So in our mind, they should already have these measures in place. They don't need to do anything out of the ordinary, extraordinary, if they've already got these measures taken care of, because these events are very rare. As far as the first part of your question, what's going to happen when the CME arrives a million miles from Earth at that L1 point? Well, our forecasters are on duty at the time when that happens to arrive. They're going to verify that indeed that is arrival because of the engineering aspects of our spacecraft out there. Sometimes we have things that aren't exactly correct. So they'll verify the information, and once they verify it quickly, then they will probably immediately send out a warning, or at least begin to monitor. The first warning they'd send out is this thing we call that sudden impulse warning. That's really directed for the power grid, but people that subscribe to that product or look for it, that's an indication that a CME has arrived. Normally that's the case. The next measure they do is send out at some point in time, based off the orientation of that magnetic field in particular, but that'll be taken into account quite a bit at what level of warning they put out. But they'll begin to put out a series of warnings. The first one would be for an index that we use to measure geomagnetic activity called the KP index, and that would be a KP of 4 index warning. That would be followed by the KP of 5, which equates to G1. That warning would go out at some point in time, followed by the G2 and G3. We stop at KP7 or greater, G3 or greater event. The reason we do that is because things can escalate so quickly that it gets out of control on how many people we're contacting and notifying. But the alerts continue to go out. So as we reach these levels of activity, every single level that we reach, an alert will be sent out. And this will be repeated for the KP of 5, the G1 and above levels, each time we hit it. And these are measured in 3-hour periods. Think of it as a rain gauge. You get a rainstorm come in, you go out and measure it, and it's got half an inch in there. The rain doesn't quit, but still going, but it slows down. You go out 3 hours later, and it's, a quarter of an inch. Later, it's an inch. The storm continues, but it's at varying levels, and that's really because of these magnetic field deviations I talked about. So nobody should think that the storm is over just because conditions quiet down for a little bit. It could turn around and be very quick to develop once again. Hopefully that answers your question there, John.
Thank you very much.
The next question comes from Christine Fisher from CNN News. Thank you.
Hi, thank you all so much for doing this call. 2 questions for you. My first is just, you guys have talked a lot about how rare this is. You use words like significant. I'm just curious, what is your level of concern right now that this could have some serious ramifications here on Earth in a way that we haven't seen before? And then my second question is, we've got a bunch of astronauts up at the International Space Station. What is the level of danger to them? Thanks.
Yeah, thanks, Chris. And I'll address the thing as far as our level of concern, and I think Rob here is very qualified to talk about the astronauts since he used to support them He still does, of course, here at SWPC, but he used to work over at Houston doing that support. So, Kristen, as far as our concern, yeah, we're a little concerned in the fact that we haven't seen this in such a long time, that we thought it warranted special attention. And with our government involvement now and knowing that these space weather storms, because we rely upon satellites in space and our cell phones and our power grid, the way it works, has become very involved with legislation and bills that are dictating that we do a better job with space weather events for planning, for coordination, and for forecasting. So bringing research to operations and operations back to research to focus on the things we need to do a better job. So therefore, the government wants us to do exactly what we're doing, much more than they have in the past. So we've been very proactive in that sense. We've discussed the situation with FEMA, and this is really for their preparatory. Not that we're expecting a massive catastrophic collapse of anything, but they want to know now because they need to know. So they're an intimate core partner of ours, and I'll be talking to them briefly once again, giving them another update here shortly. I'll actually have to step away here in another minute or two myself to talk to such folks and our partners. And that's how we articulate it to them, is how we're doing it to you, similarly, but focused on their specific needs as they need to understand it. So yes, our level of concern is high enough that we want to make sure they're aware, they know this is about to happen, they're prepared for it, and they can take the steps that we rely on them for to mitigate any issues. And with that, I'll turn it over to Rob, and unfortunately I have to step away, everybody, and this was Sean Dahl. My last name is like D as in dog, D-A-H-L. Thank you, Rob.
Okay, with respect to the astronauts on the International Space Station, there's a group at NASA called the Radiation Analysis Group dedicated to astronaut safety with respect to space radiation. And that's really the biggest concern. They do, because the space station is in low Earth orbit from our magnetosphere. Although they're high enough up there, there are some areas that are vulnerable. And during a geomagnetic storm, the environment changes such that they're a little more vulnerable to radiation events. So should we have a stronger radiation, that could have an impact. And we communicate with NASA daily, at least once a day, and during events like this, multiple times a day, to keep them apprised of the evolving space weather situation. And they, in turn, can use that information with regards to astronaut protection. In significant cases, there are places in the space station that are more well shielded based on the distribution of mass, and astronauts will move to those areas to seek some safety from that. The other interesting point is, because we're planning on sending folks back to the lunar surface, to the moon, this is another consideration that they'll have, because the moon lacks a protective magnetosphere. So they're developing procedures and ways of mitigating impacts of these events.
Thank you. And you guys have talked so much about the power grid. Can anybody just address the potential impact on, like, ATMs or cell phones?
Hi, this is Brent Gordon. I'll take that. Thank you for the question. Direct impacts on those technologies, we've not seen any evidence in the past that that space weather storm could impact that. Now, if power is not available for those, then yes, certainly, the secondary impacts from that would be great.
Our next question comes from Katrina Miller from the New York Times. You may go ahead.
Hi, I had two quick questions, hopefully. The first was, when was the last G4 storm? I'm seeing conflicting information on the website and what's being told here. Like, I keep seeing that it's the first severe storm watch since 2005, but then elsewhere I see that there was a severe storm March 2024. So if someone could confirm that, that would be great. And then my other question was, should we think of the solar storm watch as the way we sort of think about a tornado watch versus a tornado warning, as in, like, we're on guard with a watch that you can go about your business, but when there's a warning, you should head to the basement? Thank you.
Hi, Katrina. This is Mike Betwee, the operations chief here at SWPC. I'll take the first question. The last observed G4 was indeed in January 2005, and that's when we had our last watch out as well. So that was the last significant G4. We did have a G4 event. We've actually had 3 of them so far this solar cycle, which began in 2019. We've had 3 since then. They've all been rather weak. The last one, like you noted, was in March of this year, March 23rd. And it only lasted for about a couple of hours, and it was on the low end of the G4 scale. So we didn't see too many impacts from that. So what we're expecting over the next couple of days should be more significant than what we've seen, certainly so far this solar cycle. And then your second question, I think, was correlating this between tornado watches and warnings, and I think Brent is going to chime in for that.
Yeah, sure. Hi, Katrina. I think that's a great analogy to compare them to tornado watches and warnings. You know, the geomagnetic watch that we have out right now is really saying, you know, get prepared. You know, something is coming. The warning is, you know, it's here. You know, it's high confidence. We know it. We're going to get hit. You know, similar to a tornado warning. You know, it's saying duck. And yes, this is the first time we've issued a G4 watch since 2005. But yeah, we've certainly issued many warnings this year already for the G4 level. Thank you.
Thank you.
Our next question comes from Steve Herman from Voice of America. You may go ahead, sir.
Thank you. Society is a lot more dependent on GPS since it was in 2005, and that technology obviously did not exist at the time of the 1859 Carrington event. If we hit G4 or higher, what are the likely noticeable issues with navigation and other GPS-dependent devices in North America and Europe, from an event of this level?
What can happen during, this is Rob Steenberg, by the way, what can happen during these geomagnetic storms are the creation of areas within the layer of the atmosphere called the ionosphere that disrupt the signals from the GPS spacecraft between those and the receiver on the ground. In some cases, in the most severe cases, you'll see an actual loss of lock. So the receiver will lose lock on the satellite, and then that information, that navigation, position navigation and timing information will be unavailable until it is able to reestablish the lock. Now, these features are, in a relative sense, relatively small, and they move very quickly. So outages, with any luck, should not be prolonged. It's going to depend on the number of spacecraft that are available to connect to the receiver and where they are on the horizon. Additionally, nowadays, there are several global navigation satellite systems out there, and many more modern receivers take advantage of those as well. So there's a wide variety of spacecraft providing information about position, navigation, and timing. And so while the threat is there, it is mitigated somewhat by the presence of all these spacecraft.
Thank you.
Our next question comes from Kimberly Miller from Palm Beach Post. You may go ahead.
Hi, yeah, thank you so much for doing this. So earlier a question came about the watch and warning. So what should people be taking action on if a warning is issued? What should we be doing?
So this is Rob Steenberg. I'll take that. So for most people here on planet Earth, they won't have to do anything. And if everything's working like it should, grid will be stable. They'll be able to go about their daily lives. In certain sectors of the economy, like the power industry and aviation, there's some mitigating efforts that they'll have to take to work around the particular storm. But in general, the biggest thing and the most visible manifestation of space weather is the aurora. And so if you happen to be in an area where it's dark and cloud-free and relatively unpolluted by light, you may get to see a fairly impressive aurora display. And that's really the gift from space weather is the aurora.
Yeah, Kimberly, this is Brent Gordon. I'll add to Rob's good response by saying, the big difference between a tornado warning and a geomagnetic storm warning is, in addition to the phenomena that we're talking about, but it's the intended user. So whereas a tornado warning is broadcast to everyone, essentially get out of the way. We're targeting a very specific audience. Those that provide protection to critical infrastructure, such as the power grid, so that they can take the necessary actions to harden those resources, so that everyone else on the planet doesn't see any issues.
Any chance South Florida is going to see an aurora?
Perhaps with your phone. You may not be able to see it with your naked eye, but if you have a clear night and not many clouds and you put your phone to the sky, you may actually get an image or two. I mean, we have seen, with some of the recent events,
South Texas.
We've seen them as far as South Texas and even, I think, a couple down to Central America. So it is possible, not likely, but it is possible.
Just to aim it at the sky and take a picture?
Yes, and then you may be surprised when you look at that image later. Might be actually a nice little treat there for you.
Thank you so much. Thank you for answering the question.
The next question comes from Chad Merrill from WOAY TV. You may go ahead, sir.
Oh, greetings. Can everyone hear me okay?
Yes.
Okay. So I have a couple of questions here. First of all, will the aurora potentially interfere with the visibility of the International Space sighting, which is expected in my area early Saturday? That's just one question. And the second question correlates these CME events and auroras with the solar cycle. There appears to be some sort of a relationship between the CMEs and the aurora borealis occurring during and just after the peak of the solar cycle, such as the 1859 Carrington events in solar cycle 10 that Sean mentioned a little bit earlier. More recently, the Halloween storm in 2003, which occurred during solar cycle 23. And then in the current solar cycle 25, we've had a couple of them. So do you expect additional strong CMEs and auroras to continue over the next couple of years as we reach the peak of solar cycle 25 and then head towards the end of the cycle? And it also appears that the sunspot numbers have been exceeding forecast guidance since the start of the solar cycle 25. So is it possible that in a couple of years we could see a repeat of the 1859 CME events and aurora before the current solar cycle 25 ends in a few years?
Okay, this is Rob Steenberg. Have to remind me if I miss one of the questions, but in general, I'll try and work backwards. We've looked very hard, we meaning here at SWPC and the entire scientific community built around the space environment. We've looked very hard at what the probability of another event like the 1859 storm is, and we've seen percentages ranging from 2 to about 12%. And so I can put that out there. Thing is, there's nothing definitive that I can point at right now and say, yes, within X number of days we're going to have another Carrington event. That's always the big question. In terms of the solar cycle performance so far, relative to the To the prediction, yeah, it's been outperforming the prediction, the initial prediction anyway. But we've been kind of updating that as we go, which is kind of a new thing for us. We used to put one out at the beginning of the cycle and pretty much leave it alone. But now we're trying to do a better job of updating, because as Sean mentioned earlier, the atmosphere, the thermosphere and ionosphere, those changes related to the solar cycle impact satellite operators, particularly those in low Earth orbit. So they're interested in keeping an up-to-date idea of where things are going with the cycle. What am I missing? What?
Yeah, so my last question was, if we do have a significant aurora overnight and we're able to see it as far south as, West Virginia, that would be late tonight, early tomorrow, and the International Space Station sighting is in my area around 4:20 a.m. tomorrow. If the aurora happens, could that light interfere with the visibility of the ISS by chance?
I think it could, because you'll be, assuming you're cloudless and you could see the ISS, you're going to have aurora, potentially aurora between you and it. So they'll be looking down at the top of the aurora while you're looking up at the bottom of the aurora. It's really going to have, there are so many factors, including, how far south the aurora is, where the station is on the horizon. So you may get a glimpse of it, you may not get no glimpse of it, or you may just get to see the whole thing. So it's really hard to say at this point. But I would encourage you to, if you're interested in the space station, definitely a few days from now, take a look and see if they got any good shots of the aurora, and I'm sure they'll probably broadcast those anyhow.
Yeah. Okay. Thank you very much. I appreciate it.
One additional comment in regard to that, Chad, would be the uncertainty in regards to the timing of this event. Because you mentioned late tonight into Saturday morning. There's a good chance that it could be delayed and the peak of the storm will be later on Saturday into Saturday night. So just keep that in mind with the timing of when the greatest impact is going to be from this event. We're saying as early as later today through the weekend, because pinning down the exact time is quite difficult. So
Chad and all, this is Brent Gordon. I'll add to that by saying there are still many CMEs out there, and more than likely more on the way. We could see this extending through the weekend into early next week, the way things stand right now.
And I remembered one more of your questions. So relative to the solar cycle, yeah, we're heading to solar max. We're probably potentially in it. We'll see. We only know that after the solar maximum has occurred. But there are absolutely more chances for big events as we crest the solar cycle peak and then head down towards solar minimum. So, the frequency will become less as the closer we get to solar minimum, obviously, but, the threat remains, and that's why we're here.
And I'll say one more comment, and then I'll be quiet. In regard to what Rob was just mentioning there, if you look back in history, some of the biggest geomagnetic storming events have occurred on the downside of the solar cycle. People often get very excited as we're heading towards that peak, and when we think we're approaching the peak, we're thinking, oh, maybe this is going to be the prime time, but actually we tend to get very big storms after that peak as well, so just keep that in mind.
So would an example of that be the Halloween storm in October of 2003?
Yeah, I think that's a good example. I can't remember exactly when the cycle peaked back then, but it was
I think it was about
at least 1 or 2 years.
I think it was 2. I think the peak was in the fall of 2001, so that would have been about 2 years after the peak.
Okay. All right. Good to know. Thank you very much.
Well,
our next question comes from Peter Vogel from Catholic Newspapers, Vancouver. You may go ahead.
Yes, thank you very much. I'm interested to know if the auroral activity this time might be enough to actually produce an aural, as in sound, component.
This is Rob Steenberg. I have never really considered that, so I don't, that's not something that we typically forecast. We think that we're going to have a pretty decent storm, though, and if that accompanies the aurora, then, you know, in terms of likelihood, it would be more likely than not with this storm, based on what we're expecting.
Okay, thank you. But we do have sometimes crackling events with these auroras, is that correct?
I've heard reports of that, yes. I've unfortunately never experienced it personally.
Okay, thank you very much.
Our next question comes from Justine Kalma from The Verge. You may go ahead.
Hi, thanks so much for the call. I wanted to ask if you can expand more on how subsea fiber optic internet cables would be affected, and then what precautions, preparations can be taken to avoid any internet disruptions, and then also wondering what the mechanism is that allows cell phones to capture the aurora, even if our eyes can't. Thank you.
Okay, with respect to the undersea optical cables, fiber optics, those won't be affected directly by the geomagnetic storm, but what can be affected are the repeaters along those lines that continue to transmit the signal down the chain. Those rely on power, and that power can be affected by that. But I don't think we have any real-time experience yet with a significant storm in fiber optic cables under the sea. But I think from what I've read, there would be impacts, but they should not be to the level that would disable them.
Does that mean that we wouldn't expect any internet outages?
Off the top of my head, no. Unless there was a significant power outage that lasted for a while and started taking down these repeaters. And the great thing about the internet is, it's the internet, so there's other ways to route things. So even if you have some localized impacts, we can work around those.
Yeah, and Justine, this is Brent Gordon. You know, your question about the cell phone, the way I can most simply describe it is cell phones are much better than our eyes at capturing light. You know, just go out on your, go out your back door and take a picture with a newer cell phone, and you'd be amazed at what you see in that picture versus what you see with your eyes. So because of that, because they're much more tuned to a visible wavelength than our eyes even are, that's how we're seeing these images of the aurora so far south.
Thank you. And I'm sorry, can I get the name of the first speaker who answered my question about the subsea cables, as well as if there were any precautions that those operators were taking?
So my name is Rob Steenberg, and I'm not aware directly of any precautions that they're taking at the moment, but our goal is to keep everybody aware of how things evolve. But that's not a sector I've dealt with directly, so I can't speak too much to what mitigating actions they take.
Our next question comes.
I'm sorry, I just want to jump in here for a second, Sandy, and say that this is going to be our last question for the conference. We have gone past the hour mark.
Thank you. The last question will be from Cody Boatler from the Baltimore Banner. You may go ahead, sir.
Hey, thank you all, and thank you guys for putting this together. I really appreciate it. I know we said earlier, and two quick things. I know we said earlier you don't love to predict how far the auroras might go south, and I'm just wondering if once the CMEs hit that 1,000,000-mile mark, there might be any more certainty to those forecasts, whether they're from the Space Weather Center or from like the Alaska Fairbanks Institute. And then I know we talked about the ISS. I'm wondering, is there any risk to other satellites further out in space? I'm specifically wondering about the James Webb Telescope.
So these this is Rob Steenberg. So the CMEs, you will have sometimes energetic particle events, the space radiation storms that Sean mentioned, concurrent with these CMEs, and also when CMEs pass, sometimes we'll see a bump in the radiation environment. And depending on the spectrum of the particle energies and the numbers, those can, in fact, impact satellites. Now, as far as specific missions are concerned, NASA monitors the health and the environment around each of their missions, so they'd be more well-positioned to speak to that particular telescope. And then with respect to the Aurora, we do get a better understanding of the CME as it passes the L1 point. And our short-term Aurora predictions, take that information into account. But the key thing is that we don't, as it passes L1, we don't see the entire magnetic structure. We just get the beginning of it, and it evolves as the cloud passes the spacecraft. So even though it's there, we don't know what the rest of it looks like, and that just unfolds over time. It's only after it's passed that now we have a record, and we can look at it and say, and we can take that information then and use that to refine predictions and things.
And that moment could come as soon as this evening, or it might be into this weekend. We just don't know for sure yet. Correct?
Correct. Yeah, the timing remains uncertain.
Thank you.
You're welcome. Thank you.
That was the last question.
Thank you so much, Sandy. And thank you to everyone who has joined our call today.